Pipelines like this are expected to last for at least 100 years with a minimum of maintenance. To do this, they have to meet exacting standards of design and manufacture for structure, conduit and durability. Pipeline design is carried out by a project design team. Pipeline design incorporates hydrology, hydraulic sizing, route selection and alignment, and conduit selection. The design team must sign off on pipe load class, pipe diameter class, classification of use, and the environment it will be placed in. The design needs to comply with the Australian and New Zealand standard, AS/NZS 3725, designed for the installation of buried concrete pipe, as well as other accepted codes of practice such as industry and CPAA specifications. While the project design team is responsible for the pipeline design, the actual pipe design is the responsibility of the manufacturer. The pipe needs to have the requisite strength, hydraulic performance and service life performance to meet the project design team's expectations. Steel reinforced concrete pipe has to be manufactured to meet the requirements of the Australian and New Zealand standard AS/NZS 4058, precast concrete pipe, pressure and non-pressure, and to satisfy the criteria of structure, conduit and durability. The manufacturer must ensure that concrete strength, reinforcement configuration and position, and pipe wall thickness satisfy the requirements of the nominated load class. The load class number signifies how strong the concrete pipe is and is clearly marked for identification. Class 2 pipes are designated as standard strength. Class 3 and 4 are extra strength pipes, and Class 5 pipes and above are special strength. Unreinforced pipes have no marking. The manufacturer is also responsible for supplying actual dimensions and nominating the correct joint configuration for the application to ensure the conduit criteria is met. Reinforced concrete pipe can be designed and manufactured from small diameter to large diameter in accordance with AS/NZS 4058. They're classified into 3 different joint types: rubber ring jointed pipes, flush jointed pipes and jacking pipes. With an expected 100-year plus service life, the pipe has to be manufactured to withstand all contingencies. Aggressive environments may be encountered both inside and outside the pipe. For example, pipes may be laid where groundwater contains sulfates, or the line may end in a saltwater tidal zone. It's the manufacturer's responsibility to produce pipe made in accordance with the standards. In the vast majority of applications, the standard concrete pipe will meet the requirements, and responsible definition by both pipeline and pipe designer will assure product performance. Before the pipe is made, the mould needs to be prepared. Once it has been oiled to allow the concrete to be removed, the steel reinforcement cage is added and placed accordingly to obtain the specified cover. The placement of the steel reinforcement cage plays a critical role in the pipe's field and test performance, and its configuration is the result of both theoretical design and many years of practical evaluation. The mould is then put into position, ready to make the pipe. AS/NZS 4058, Precast Concrete Pipes Pressure and Non-Pressure, is the base document for manufacturing, and CPAA members undertake to comply with this specification, irrespective of manufacturing techniques. These include traditional methods such as roller suspension and centrifugal wet spinning, as well as new methods such as vertical dry casting. Vertical wet cast methods are used for very large diameter pipes. The roller suspension method has the mould suspended on a rotating steel roller. Concrete is poured against the inside wall of the mould and is compacted by the roller. Using the centrifugal wet spinning method, controlled vibration allows the concrete to compact against the inside wall of the mould as it is poured in. These 2 traditional methods of making concrete pipe are used throughout Australia and New Zealand. In vertical dry cast applications, the concrete is poured into the mould and the vertical rollers operate mechanically to compact the concrete against the mould. Once the concrete is placed and compacted in the mould, the cement commences hydrating and the concrete curing process begins. This is generally done at an elevated temperature using low pressure steam and has the effect of accelerating strength development to expedite handling. After this initial curing, pipes are demoulded, marked and placed in a stockpile to continue further strength development prior to proof testing, final inspection and delivery. The principal test to validate the structural adequacy of the steel reinforced concrete pipe is the load test. Its fundamental purpose is to validate load class nomination from statistically valid samples of pipe populations. This testing ensures the structural aspect of pipe criteria is met. A pipe may well crack during this proof load testing, and the crack will close when the applied load is relaxed. The integrity of the pipe is not affected by cracking during proof load testing. The standard AS/NZS 4058 specifies the maximum allowable crack width at proof load, in line with the cover of the reinforcement of the pipe. As in all concrete design, steel reinforcement takes the expected load once the concrete cracks. Steel reinforced concrete pipes are also tested to ultimate load. The ultimate load required to be met is factored from the designated proof load and is outlined in AS/NZS 4058. This test ensures that the pipe can handle the maximum load it is expected to be subjected to on site. When a pipe reaches its ultimate load, it does not fail catastrophically. However, it is rendered unserviceable. The pipe deflects and a final collapse will occur when the reinforcement and the concrete cease to bond. The conduit criteria can be validated in several ways. The hydraulic capacity is ensured by routine diameter checking and joint adequacy, both proven by measurement. Hydrostatic testing may also be specified for water tightness verification. Pressure testing of pressure pipe is required for verification of the pressure rating. Strict manufacturing techniques demand that the concrete be of correct quality and consistency. The use of premium raw materials in both the manufacture of the concrete and the steel reinforcement assures the durability of steel reinforced concrete pipe. Prior to being delivered, pipes are subject to a release inspection at the dispatch point to ensure the load complies with the order, that they're free from visual defects and comply with the relevant aspects of plant quality assurance.